Here we have a SAT math problem. Okay, let's go to the question. There is a triangle given over here. In the figure above, AD equals to DE equals to EC. If the area of triangle is 81, what is the area of the shaded region? Okay, here we have the shaded region. Actually, the shape of the shaded region is a trapezoid because we have two parallel sides, and this D represents the height of the trapezoid. Okay, now let me assume the height of the triangle AB is just Y, and I assume the length of this line segment AD is X. Then the length of this line segment D also must be X, and this one also must be X because AD, DE and EC, all of them are equal. So now the base of the triangle is AC, which is 3X. When I add this X, X, X. Okay, it is given that the area of the triangle ABC is 81. Let me write the stuff over here. Area of triangle ABC is 81, and the formula to get area of a triangle is 1/2 times base times height. Here the base is 3X and the height is Y, which is equal to 81. Okay, now let me multiply both sides of this equation by 2 to get of the denominator 2 over here. This 2 will cancel out. Then I'm getting 3 times X times Y equals to 81 times 2. Now let me divide both sides by 3. When I do so, this 3 will cancel out. 3 goes into 3 one times, and 3 goes into 81 27 times. Then we get XY on the left side over here. On the right side, we have 27 times 2, which is 54. Okay, now I got the product of X and Y. That is X times Y equals to 54. Okay, anyways, to get the area of this shaded region, that is trapezoid, I must be knowing the length of this side and this side, the two parallel sides, so that I'll be able to get the area of the shaded region using the formula to get area for trapezoid. For that, let me consider the triangle ABC over here, and also let me mark another point. One second, ABCD. Let me mark F and G. Okay, now let's consider two triangles: a triangle ABC and triangle DFC. Okay, here all the three vertical line segments over here, AB, DF and EG, all of them are perpendicular to the same base AC. Since all of them are perpendicular to the same base AC, so all these three vertical line segments are parallel. Since all these three are parallel and BC, the line segment BC intersects all these three parallel line segments, so then BC is called a transversal. Then the angle measure over here, angle measure over here, and angle measure over here are corresponding angles, and they must be equal to each other. Okay, now I consider two triangles, that is a triangle ABC and a triangle DFC. These two triangles are similar because so the two angles of the triangle ABC are equal to the two angles of the triangle DFC. By angle similarity postulate, the two triangles are similar. Okay, now let me write the vertices. First, let me take the vertex A in the bigger triangle. What is the corresponding vertex in the smaller triangle DFC? That is D, because we have right angle at A and right angle at D. Let me write it over here. D. Now let me take the vertex B, the bigger triangle. The corresponding vertex is clearly F, because the angle measure over here and angle measure over here are equal. They are corresponding angles. And the third vertex for the bigger triangle is C, and the third vertex for the smaller triangle is also C. So these two triangles are similar. If two triangles are similar, then the ratios of the corresponding sides must be equal. That is, the corresponding sides are proportional. Okay, now let me take the side AB in the first triangle. What is the corresponding side in the second triangle? For that, we have to consider the letters at the same position, that is DF. Okay, now let me take the side AC in the first triangle, that is AC. Okay, the corresponding side in the second triangle is DC. We have to consider the letters at the same position. Actually, I don't consider the side BC because I don't have any information about the length of the side BC, so I don't consider the side BC in the first triangle, and also I don't consider FC in the second triangle as well. Okay, we know that the length of AB is Y, that is we have assumed, so we can plug in Y for AB, and for DF, I do not know the length, so we have to write DF as it is. And for AC, we know the length is 3x, and for DC, we know the length it's 2x, because DC means we have to add this x and x, then we get 2x, this x will cancel out. Then I'm getting Y over DF equals to 3 over 2. Okay, now let me take a reciprocal on both sides, and I'm getting DF over Y on the left side. When I take reciprocal for this 3 over 2, I'm getting 2 over 3. Now let me multiply both sides of this equation by Y. Then this y will cancel. Then I'm getting DF equals to 2y over 3. Okay, now I got the length of for this vertical line segment, that is 2y over 3. That is, in this trapezoid, I got the length of one of the parallel sides. Okay, now mine is to get the length of this line segment GE. For that, we have to consider the two triangles, the bigger triangle ABC and the smaller triangle EGC, and we have to do the same work, and we have to get the length of this line segment GE. Okay, now let me do that. Okay, so first let me write the vertex A in the bigger triangle. The corresponding vertex in this smaller triangle is E. Let me write it. And let me take the vertex B in the first triangle, and the corresponding vertex is G. And the third vertex for the bigger triangle is C, and for the smaller triangle also the same third vertex we have. These two triangles are similar. Okay, now let me take the side AB in the first triangle, and the corresponding side in the second triangle is EG. And now let me take the side AC in the first triangle. The corresponding side in the second triangle is EC. And for AB, we know that Y, and for EG, we do not know the length. That's what we have to find. And for AC, we know that it's 3x, and for EC, we just have x. Then this x will cancel out. Then I'm getting Y over EG equals to just 3 over 1. Now we can take reciprocal on both sides, and I'm getting EG over Y equals to 1/3. Now let me multiply both sides by Y to solve for EG. Then this Y will cancel out. Then I'm getting EG equals to Y over 3. Okay, now I got the length of the vertical line segment EG, that is Y over 3. Okay, now I know that the length of the two parallel sides of this trapezoid, that is shaded region, that is 2y over 3 and y over 3. And also this D represents the height of the trapezoid, that is given by x. Now we can use a formula to find area of a trapezoid to get the area of this shaded region. Okay, now let me erase this stuff and continue the problem. Okay, now let me find the area of this shaded region, that is a trapezoid. Let me write the stuff over here. And the formula to get area of a trapezoid is 1 over 2 times height times the sum of the two bases B1 and B2. So here 1 over 2 times the height of the trapezoid is given by x, and the first base is 2y over 3, and the second base is just y over 3. Let me write over here. Then we get 1 over 2 times x times. Now we can add these two fractions, and these two fractions are the same denominator 3. So we can take the common denominator 3. Then we can add the numerators 2y positive y. Then I'm getting 1 over 2 times x times 2y positive y is 3y over 3. Then this 3 will cancel out. Then I'm getting 1 over 2 times x times y. Already we got the value of x times y, that is 54. So now what we can do is we can plug in 54 for xy over here. Then I'm getting 1 over 2 times 54. So here 2 goes into 2 one times, and 2 goes into 54, 27. So finally, I'm getting 27. So the area of the trapezoid, the area of this shaded region is 27. We find 27 in answer choice B. The correct answer choice for this question is B.